I will write a real parser, lexer, from scratch so that you know how this thing is implemented. Expression, parser, right? Let's do that. So the very first thing I should define is my alphabet. So it is in my alphabet. I have what? In my alphabet, I only have like digits, right? Digits. Let's say number, or I just say number. And then I have a plus, I have a multiple. This is it. This is my alphabet. My alphabet is so simple, so I can only do something like this. 2 plus 3 times 4 multiply plus 5. Something like this, right? No division, no subtraction whatsoever. That's my alphabet. So every single thing in your alphabet, you must have a token. Because when you split into tokens, each thing in your alphabet, that will become a single token. So let me create my token. Type token is, I have a token of number, right? That carries a single character. So my numbers are single digit, right? My numbers are single digit. I have a token called addition. I will call it token sum. I have a token called multiplication. I will call it token mul. And I have a token called this shows end of the list, right? This is it. Cool. I have my token. Now I need this string module, so I'm going to load it. That is str.cma. So I'm loading this thing to the to use a regular expression. Now let's define some regular expressions. That is, I will say let regular expression for number, right? The regular expression for number, that is string reg xp is 0, anything that 0 to 9. 1 digit, right? 1 digit. Let regular expression for ADD is equal to str regex p, that is a single symbol. Let a regular expression for multiplication, that is equal to string regex p of, that's it. So I do have my regular expressions. Now let me write a function. Let tokenizer. If you give me a string, I will tokenize it. That is, let recursive token, starting from this position, parse this s. So definitely I say if position, let me put it here. This is tedious, right? So if it string length s, then I will return the token n. That is no more tokens, right? No more tokens. Otherwise, if string str string match, it is something like this. Look at that. If it's given here, I'll just retrieve, right? I split into tokens. Like I want to get the number, I want to get the plus. That's what I'm doing. String match string. This is very verbose here. S in, right? If you can match this. Match string what? Regular expression number in S, starting from this position, Yes, this is, I should have copy pasted, but let's type it together. In, if that matched, then I say let token is equal string match string s in, and then I say token, create a token number with saying that I just got it. That is token 0. Concatenate with recursively calling this tokenizer again is token starting from position plus 1 s. Okay, so let me explain. This says, this code said, if you give me a string, right, now I'm starting from whatever is 0, and I'm going to parse this string. And if you currently, if the position is, it's outside the length, then I stop. Otherwise, I say, hey, can I match a number, right? Starting from this location, can I match a number? If I can, I'll get that as a token, and I get that very first character, that's 1 digit, and then I will continue with the remaining part. Otherwise, right, else, then it'll be same kind of code. Let me copy that. What did I do? Else if, now, if it's ADD, instead of number, if it's ADD, then I take that match string, then I will add token sum. This is addition to whatever the remaining part. I just add a token sum to the list, starting from position 1. I will continue to parse it. Now, again, if it is a case like this, now I will parse, that is multiplication, mul, then I will take that, I will say that's a multiplication, and then I will continue, right? That's it. Call. Something is wrong here, but let's save it. And then after that, I raise an exception. Raise illegal expression. Tokenizer. For that, I need to declare this exception, that is exception illegal expression of string. Okay, cool. This is my tokenizer, really. So I'm going to call this tokenizer starting from 0 with str. Save it. Let's see if this is correct. Else, then if this is true, then this, then token plus 1. That is correct also. Else, this else here, this else is here. Oh, cool. It looks like the code. So this is really a lexer. Now let's do the parser part. That is parser, right? So now let's look at my grammar, right? My grammar, that is E goes to T plus E, or T, and then T goes to P star T or P. Then I have P goes to 1 or 2, 3, ... all the digits. So this is my grammar. I want to parse that. To parse that, I need an expression tree. So for that, I need to create a new type, that is type expression. This is my AST eventually. I could have a number of int, right? I could have a sum of expression star expression. I could have a mul of expression star expression. So this says, right? This says if you want to create 10 plus 20, this maps to, right? This maps to sum num10 num20. That's it. This is my expression, and this will be the tree. That is, you have a, if I draw that, right? That is plus 10, 20. So that maps to sum, right? Num10, num20, right? Num10, num20. So we have our AST type. We have our grammar. Now let's parse it, right? Let's parse it. So I'm going to parse E. I assume my tokens are in a token list. So I say, how about I have right here, let, I'll call it token list, TOK list is equal to ref of this. So it's a reference, right? So that it has a side effect every time you remove something, other part of the parser will see it. So in the past we did, once we did like totally full functional way, no ref list, and it is, you have to send the environment every time. This is easier. So I'm going to parse this E, that is, right, parse E. Before I parse, I forgot. So I need two functions, that is look ahead, right? Let look ahead, that is, what is the next, right? What is the next thing in my token list? So I say match, get the token list, and then with, if it's token empty, if it's empty, I raise an exception, right? I raise an exception. How about I still raise that illegal expression? You should create another kind of exception for this, right? Parse error. Otherwise, right? Otherwise, and then I will match, it is head and tail. I'll return head. This is my match. Just look ahead. It's basically getting the head. Another function could be match token. If you give me an A, I say to match token, I say match token list with, if it is head and tail, I check if head is equal to A, then okay. So I implement. If this is the case, if let's say A is equal to H, then token list, I will update it with the tail. So I just remove the head, right? Remove the head. Else, I will throw an exception. That is, raise this exception again. Because in this case, I cannot parse it. Cool? Now I have my look ahead, and I have my match. Match is just, match consumes, right? Match consumes one token. This consumes one token. This one just looks ahead, right? Get the head. Cool. Now let's write our parser. ParseE. Let me copy this grammar closer to the parser so that we can look. It's right here. ParseE, very first thing, to ParseE, very first thing you do, you're going to parse T. That is, let A1 is equal to parse T. In. Now I want to look ahead. I want to see next thing is plus, and then I'm going to take this rule. If the next thing is not a plus, I will take this rule. So let T is equal to look ahead. In. Match T with, if it's a token sum, that means I have to do this rule, right? I have to do this rule. Then, right, then if it's a token sum, I'm going to match, I consume that addition, that is match token, token sum. I will consume this thing. And then let A2 is, now look at that. After I consume, I have to parse E. So let A2 is parse E in, and then now all together I have to return a sum of A1 and A2. A2, right? Otherwise, if it doesn't match, then I will just return A1. Okay, now let me explain this thing. It said, I am just parsing T plus E. To do that, right, I have to parse E. That's what I did here. I parsed T. And after that is the next token plus. If it's a plus, I'm doing correct. Otherwise, I should do the other rule that is this T. So I have to look at the next token, that's T, and I match. If it's token sum, I will consume it. This is where I consume it. And then I have to parse this E. That is parsing E. So if I parse this T, the result will be A1. If I parse this E, the result will be A2. Because of this addition, in my tree, I have this node of A1 or A2. That's what I returned right here. But somehow, if the next token is not plus, this entire rule doesn't work. I should pick this rule here. So I just return A1. Remember, A1 is the result of just parsing T. So this is the entire parse E. Now I have to continue parse. I have to continue parse. Next thing is parse T. I'll take one question. Any question? Yes.
Why do you use a semicolon?
Huh?
After token.
Yes. So it should be, I'm doing multiple things together. So this is like, you do this, remember the meaning of semicolon, you do this expression, drop whatever the value, it doesn't matter because it has side effect, it updates that a reference type list, and then continue, do this, and return this value. So that's what the semicolon means. Probably if I do this, it should be still okay. Okay? I'll just say, eval do this expression and drop the value. That's what the semicolon means. Cool. I continue. Parse T. To parse T, same kind of concept. You have to parse P. Let A1 is equal to parse P. In, right? Let T is equal to look ahead. I look ahead in match T with. Now I'm right here. If it's after P, if this is a multiplication, then I have to parse T. But I consume, like if it's a token mul, then I'm going to match token mul. Right? I consume that. let A2 is equal to this thing here. Parse T. In, I return sum, a mul of A1, A2. Otherwise, after I parse P, it's not, right? It's not multiplication. Then it means, oh, I have to pick this rule. That is, if that's the case, just return A1. Remember, A1 is parse P, see? Because whatever you parse P, that will be your result because there's nothing else, right? Nothing else. And now, very last step, I'm going to parse. What is left? What? P? Yes. Look at these people. None of them is paying attention, but it's okay. This is the most exciting lecture for me entire semester. Cool. Let, in this case, to parse P, it's just digits. There's no variable whatsoever. So I say, okay, look ahead. Is that the digit? Next thing. Let T is equal to look ahead, right? In. Is that the digit, right? Is that the digit? Then I'm done. That is match T with token num. And if that's the case, if it's a token number, then let this equal to match a token. I will consume this thing. That is token num. num. And I will consume that in, I will return something called number, right? Because I have to get that one digit. That is int of string and char escape n. Otherwise, I'll return, sorry, this. Otherwise, I will throw an exception that is raise, whatever. Where is exception? Let me copy another one. Here. I'll raise this exception. You should raise different exception based on what you're doing, but I'll just make it simple. I throw same kind of exception, okay? That's it, right? That's it. Cool, I'm done. So this thing can parse it, right? This thing can parse it. Now let's load it with 100 errors. Let's see. This is better. Let's fix that. Exertion. Illegal. Okay, let's load. 27. So, what is going on? 27, token num. Token 0, dot 0. It's an array. 90, big improvement, like 27 to 97. There's no error. Not error, it's arrow. Yay, oh no. Well, now go back, 25. String match string. So I spelled something wrong. String match, just one. Why do you have another? I didn't type that. You guys did something. Line 6. Tok. Is that it? I copy pasted. match token list with match token. It's an easy thing. Why? Match token with, if it's headed tail, original event, this, then go. Let me see. Then token list T, not else. So everything else, just throw exception, so that I don't have to do. Can I finish this today or no? Where? Which line? Can you? Then, oh yeah, oh come on. Come on. Yeah. If A is then, why? Wreck. Come on. Match took 95. What was that? Cool. Now let's parse it. Okay, let's parse it. That is, I have let T is equal to tokenize 2 plus 3 times 4. Huh? I have. Okay, cool. Yeah, tokenize. I did tokenize. Now I say let whatever this expression is equal to parse. Oh no, I have to say token list is equal to T. Is that right? So let's check the token list. I have that token list. Now do parse E. What did I do? Token list token, it starts with token sum. That is wrong. Where's 2? That is, now I'm gonna, token list is equal to T. Come on. Token list is this. Now let's parse. Hey, see? Look at that. So look at that. This thing is, it is plus, this side is 2, this side is multiplication, this side is 3, this side is 4. This thing I did not give the precedence because of my grammar is good. It automatically detected you have to do the multiplication before the addition, right? Before the addition. So that's very cool. Now I can, with that, I can write a very simple eval function and I can evaluate it. That's, just give me 1 minute. That is let rec eval function. If you give me an expression, I will match that expression with, if it's a number, n, it goes to n. If it is sum, of E1, E2, that goes to whatever you have to evaluate the E1 plus evaluate the E2. If it is mul E1, E2, that goes to eval of E1 times eval of E2. That's it. I'm going to save it. Now, I don't want to load everything, so I'm going to load this file here. Numbin. I know. It's just don't play with this thing. Good. I know. I want to load it. Cool? So now, remember E, I have this expression, so eval of E. Yes, because now I have 2 eval. Baby, stay with me. This is my tokenizer. No, use. Parser ML and tokenize. Let E is equal to parse. No. Token list is equal to T. And then let E is equal to parse E. And now eval of E 14. See? That's it. That is. Now I have 4 minutes to show. Now I'll show you cool stuff. So that is, if I go to the parsing, if I say Emacs parsing example, list that is called example parser, Emacs or OCaml, use example parser .ml. See, look at that. This thing can do more. It can do multiplication, prints. Let me see what I can do. Sum, mul, left paren, right paren. So this is definitely a little bit more. Please look at this before. You have to understand this code before you start your project for. Now, even better. So if I go to small c with types, look at that. Look at what I can do. That is, This is what I can do, right? Export PS equal to cool. Make clean, make cat test.c. See this code? This is a C code. Now I can evaluate it. Eval test.c. Test.c. It says 30. This, I have variable A is 10, B is 20. I added 30. Now I can do this. Gen code. List gen code of test.c. A code gen. Like, come on, I forget stuff. It code gen. Look at that. This is your 216. I took that C code. I just generated assembly to show you that. Test.s. Emacs test.s. See? ADDI load. This is, I generated the machine code. I can run it. That is spam.file test.s. 30. I can do, give me another minute. I can go to another one that is small c with functions. Cat factorial. See? I have function called factorial. Factorial is a recursive function. Say eval of factorial.c. 120. See, I can, even I have function calls, I have recursive calls. Entire GCC is there. So that's your project 4. Thank you for being so patient. Thank you. I'll see you on Thursday.